Welcome. Super excited for all of you to be here today. Really have a lot of great content for you and just super, super excited to be announcing the public preview this past week of Diagrid Catalyst. So that is what we are going to be focused on today. We're going to cover a lot around what Catalyst is, what Diagrid is, what the feature set is. We're going to hear a little bit from some of our private preview users to give some context on things that they've seen, really useful about the product. And then we're going to dive into a pretty comprehensive demo. So you should get a pretty good understanding of Catalyst by the end of today. So if you're new to Catalyst, which I know that there's a good number of people who have heard about it for the first time in the past couple of weeks, Catalyst is now a public beta platform. And essentially what it provides is a set of fully managed developer-centric APIs. So the same way, Square, for example, provides payment APIs, Catalyst essentially exposes a set of developer-centric APIs for implementing developer patterns. So the world of application development is not getting any easier, any less complicated. Architectural requirements are growing, security requirements are growing. And as applications become more and more distributed across compute to take advantage of the cloud scale, we see that there's a lot more that falls on the developer's shoulders to implement. And so that can be things like stateful orchestration via workflows. It can be, distributed messaging via PubSub, direct service invocation, state management, and even binding to external resources to react or respond to events in a more event-driven way. So all of these are APIs that are basically exposed through Catalyst and powered by Dapper. So if you're unfamiliar with the Dapper project, we'll definitely talk about that some today. But Dapper is essentially a set of open source APIs that have been around since 2019, are currently in the process of graduating from the CNCF, the Dapper project. So it's been around, widely adopted by many organizations, used at high scale. And we'll kind of talk a little bit about, how Catalyst differs, where Dapper fits in. But ultimately, yes, that is what Catalyst is a set of developer APIs. And like any public APIs, like any scalable managed APIs, you can access them from any language or framework. Lots of great integrations from an SDK perspective, completely compliant with the open source Dapper SDKs, so very consumable. And then you can essentially connect and integrate with over 30 different services to power your APIs from a backend infrastructure perspective. So we'll also dive a lot into what that looks like and the steps for getting up and running with Catalyst. But that's Catalyst at a glance. So if you're unfamiliar with Diagrid, just wanted to kind of emphasize the Diagrid mission. Diagrid, the company that has created Catalyst, really started from the co-founders of the Dapper project. So that's why we believe so much in it. That's why we've seen and been so close to all of the projects using Dapper and the customers seeing wide value in what Dapper provides. And so Mark and Yaron, who created the Dapper project, started Diagrid with a mission to essentially help continue to push productivity within the developer space, right? How can we take not only the Dapper project, but other productivity concepts in order to help developers be more successful navigating this more complex development ecosystem? And so that is really what motivates all of us at Diagrid to build new products, including Catalyst, as we feel this can really, truly catalyze and enable you to build new applications more quickly, right? And that's the overarching goal. So if you've never used Dapper before, it essentially, like I said, is adopted by several organizations that you can see here. Ignition Group, we have IBM, lots of different adopters of the Dapper project. And when surveyed in the State of Dapper report, which we are about to do for 2024, this is from the 2023 survey, but essentially, what do you like about Dapper, right? It makes building microservices faster and easier. And that's ultimately a value proposition that we at Diagrid want to continue to embrace. Another thing is the lack of code changes that are required to get infrastructure portability, being able to make applications simpler, more secure, and more reliable, right? So these are all things that Catalyst is aiming to bring in and expose with less operational overhead. So just kind of wanted to highlight, what does Dapper do and why is Catalyst capitalizing on this Dapper momentum? It clearly solves a lot of microservices challenges. So Diagrid really is better together with Dapper. So if you see the Dapper logo, we want you to think of Diagrid. When you see the Diagrid logo, we want you to think of Dapper. It's a better together story. We want to make microservices easier to develop, and we do that by continuing to amplify and improve the Dapper project. And this is not only through our products, but also through deep involvement in the open source ecosystem and the ongoing Dapper releases to continue supporting that project. So Dapper today is fairly confined to the world of Kubernetes. And that's really the big challenge that we see from a lot of developers is Dapper is great. It provides these great APIs, but I have to essentially run them in containers. I have to run them on Kubernetes. I have to manage the Dapper deployment. And we've seen over the past several years a trend for people who are saying, you know what, I don't want to manage a full Kubernetes cluster. I don't want to manage all of this infrastructure, right? And that's a pervasive pattern that's happened in trend that's been going for many years as the cloud has been incepted. And so ultimately, we want to try to say, how can we as Diagrid make developers more productive? Well, we can start by bringing Dapper to more people, right? It's already proven to help developers improve their productivity. So how about we bring it to more developers outside of the Kubernetes ecosystem, developers who have a proclivity and interest in managing the least amount of infrastructure required in order to get their applications up and running. So really, that's where Catalyst comes in. So when it comes to Dapper, Diagrid provides two different paths. One is operationalizing Dapper on Kubernetes. So this is really kind of the open source to management path. And then we also have users who maybe are interested in Dapper or interested in some of the value props it provides, like simplifying microservices development. We essentially now provide Dapper as a fully managed project through Catalyst. So the same Dapper APIs that have been proven in the open source ecosystem are now consumable via the Catalyst platform without the constraint of running it yourself on Kubernetes or running your workloads on Kubernetes. And so our goal is really, how do we make Dapper more accessible to more users? We can do that in this way through Catalyst, which is the product that we're talking about today. So hopefully this helps differentiate for you a little bit, how does Dapper kind of fit into the picture? How do Catalyst and Conductor sort of relate? And to me, I really think they're for different audiences. There are some use cases where you're running open source Dapper and you find that Catalyst is a great fit to help to offload some of that responsibility, or maybe existing Dapper users. For example, Whit is on the call today. Whit is a great Dapper user, a great Dapper contributor, and he actually uses Dapper on container apps, right? So that is one platform that currently supports Dapper natively, and we're trying to bring this to more platforms like ECS, other AWS services, GCP Cloud Run, things that don't necessarily have that native integration. All right, awesome. So when we're looking at Diagrid Catalyst, the platform, right, we kind of understand the core concept and what it's aiming to achieve. But ultimately, there are 5 APIs that it exposes today, all of which are backed by these Dapper open source APIs. So we have the workflow API for stateful workflow orchestration, which we will actually see all of these in the demo today. So you'll get a really good taste of like, what does it look like to make use of these in practice? We have that PubSub API, the state API for data management and retrieval, the invocation API, which is really powerful, right? This is one I'll just kind of briefly touch on in a more contextual sense, which we'll see in the demo. For example, let's say that you're running something on Kubernetes and you're running something on Lambda, or maybe you're running something on Azure Container Apps and something on AWS App Runner, right? You may have different pieces of code or logic that are running on different platforms, and they don't necessarily have a shared native kind of network overlay in order for them to address each other with resiliency out of the box, tracing out of the box. And that's what invocation through Catalyst allows you to do, right? As I can actually connect 2 disparate workloads running on 2 disparate infrastructure services, potentially even across networks, with a kind of consistent network overlay. So really, really powerful stuff when we think about some of these more tangible use cases for how Catalyst is enabling developers to kind of architect solutions in a different way. And then finally, we have bindings, which once again, we'll see this today in the demo. This is a really good way. Once again, I might want to have an output binding to a particular service. I might want to react to an event that comes into Azure Blob Storage, for example, right? All of this is possible through that binding paradigm, which is very familiar within the serverless and functions-based programming model. I also do see we have a question. So Alice said that she would answer questions. That wasn't a question, so that's great. Thanks, Alice. So if we look at Catalyst at a glance, really it's API first, right? So this is a quick GIF is just showing you how the APIs look. So we basically have the workflow API, the PubSub API, and they follow a very standard, REST-based interface. So very easy, very to consume, and they're all accessible over HTTP, gRPC as well. And then there are SDKs across all of the different languages. So you get really good consistency, right? This means I can publish a message the same way in C# as I, .NET as I do in Python. And so even though I might be interacting across services, frameworks, languages, I still get like a very consistent interaction model through which I can communicate and build my services. It's also extremely flexible. So we talked about not requiring Kubernetes, but really this means that you can essentially host your application on any hosting platform that suits your needs across the major cloud providers and even potentially on-prem. So just kind of wanted to highlight that it's super flexible in terms of where the application runs, because you're no longer having to think about, oh, I need to run Dapper on Kubernetes, and therefore my workload needs to be co-located as well. And then, like I said, it's integrated. So you might recognize some of these icons from DynamoDB, Redis, RabbitMQ, right? Whatever backing infrastructure you want to use becomes a complete platform engineering decision that can be abstracted from developers. So this is really good for a couple of scenarios. One, maybe dev test, right? So if I'm running in development, I might use Redis in order to save costs or optimize a particular development environment. And then when I go to my staging environment, I might want to use, Redis running in Azure, or I might want to use DynamoDB and AWS. With this consistent API interface, you can swap out the infrastructure without changing the code. So it's really powerful from like an environment perspective, but it's also powerful if you want to future-proof your application, right? More and more services are being created every day, and the use case for your application might change. So having the flexibility to say, hey, I want to swap out this underlying provider becomes no longer a huge application rewrite effort, which we see a lot at organizations. And, after several years, they end up rewriting an application and it becomes a significant migration effort. So Catalyst really enabling that even more broadly, on top of what Dapper already provides. So I want to talk now about how Catalyst specifically works. So the first concept that I want to cover is an app ID. So let's say you have an application and your application is running on any of these compute platforms I mentioned before. You're essentially going to create what's called an app ID in Catalyst. And this essentially acts as the identity for that external application. And that identity has things associated with it, right? Some of it is authentication related, like API tokens, and some of it is configuration related, like what state stores it can access, what PubSub brokers it can access. So an app ID really needs to be kind of a one-to-one resource in Catalyst for all of your external microservices. So in this GIF, you can kind of see the way it works in the Dapper world versus the Catalyst world. So in the Dapper world, you have your application and you have your Dapper sidecar. They communicate over a local host and they're both running on Kubernetes. In Catalyst, you have your Catalyst app and your Catalyst app ID. That app ID exists in the Catalyst space and is hosted by Diagrid. In the case of right now, it's running in AWS West US. However, we will have more regional availability to ensure that app ID is running co-located in the same region as your application workload for obviously latency and performance reasons. And then on top of that, instead of calling over localhost, you're now calling over a TLS encrypted channel. So you're now making a call to your Catalyst project versus the local sidecar. And so that's really how it relates in the Dapper space. If you're familiar, that should make a lot of sense to you. If you're unfamiliar, it should help you bridge that knowledge gap, hopefully. So if you have any questions there, please let me know. But the app ID is really the main primitive that you start with whenever you want to create and work with the APIs. So after you have your app IDs created, you can configure your API resources. So as I mentioned, and if we go back to this slide, we can see that we have a v1 publish endpoint. So in this specific example, we have to choose where are we going to publish, right? I'm telling Catalyst that I want to publish a message. Where do I want to publish it? And really, that's completely up to you, as I mentioned. So it can be Azure Service Bus, it can be RabbitMQ. you'll see kind of a screen grab of the console in Catalyst. And what this allows you to do is essentially configure the backing infrastructure resource that is used by the API. So for example, I can go ahead and configure a pub sub component for SNS SQS. I tell Catalyst how to connect to that resource, and then the publish endpoint will then use that to make the publish call. And so that's kind of the second major resource in Catalyst. So you have your app IDs, you have your components, which represent the backing infrastructure used by the APIs, and then you can connect your apps. So unlike other API platforms, Catalyst is slightly unique in some scenarios, and this is because some of the connectivity needs to be bidirectional to the platform. So I'll give you a couple examples. If we take a look at the node subscriber here, which I think maybe I can zoom in a little bit here. Yeah, so if you take a look at this node subscriber, this is one of our application IDs, and we can see that we've configured our APIs. And in this case, we have a pub sub component that is AWS SNS SQS. And then we also are using a Diagrid infrastructure broker, which we'll discuss a little bit more in detail. But Diagrid also provides managed infrastructure resources to make the getting started and general management and operations of your solutions easier, right? So we can see the components, we can see the app ID, but we can also see this app connection section. So there are times when your application needs to receive outgoing requests from Catalyst. So a good example of this, if I'm publishing a message, I make a request into Catalyst to publish the message. But if I'm subscribing to a message, if I want to listen to what was published, I need to also be connected to Catalyst from an endpoint. So that's an example of what an app connection is. So this app connection can be like your local development workstation during local development. It could be an app runner endpoint, a load balancer endpoint, right? Whatever that might be for your use case and where your application is running. But that's a requirement today, at least for things like input bindings, subscriptions, and some of that's going away. So that's one thing I do want to touch on is a good example of this. One of the features we're going to be working on in Catalyst is support for streaming subscriptions. So this would mean that the subscription is initiated dynamically from the application, which would only require an inbound connection. So the goal is eventually you won't necessarily need to put endpoints in on your applications, for your app IDs, but you do today in order to get some of those events delivered to your endpoint. So yeah, those are kind of the three main concepts: your app ID, your API resources, and then connecting your apps to make use of the APIs, both requests going in and outgoing requests coming out. Last thing I wanted to touch on just briefly on the interacting with the API side, which is ultimately like the main objective for Catalyst, right? Is I want to make an API call. We've done a lot of things to make this even easier for you. So a good example of this, when you go into your Catalyst project, you'll see that there is a connect to project option. When you go to that connect to project option, what you'll see is the main environment variables that you need to connect your app to Catalyst. So in this case, you're going to set a Dapper HTTP endpoint environment variable, a gRPC endpoint environment variable, and a port. And essentially what this does is when you're interacting with Catalyst through the Dapper SDKs, which is what we recommend, you will configure these environment variables. The SDK will pick these variables up by default, and it will connect you to your app ID. That's essentially what's happening here, right? I want to connect from my app to my app ID. And then once again, we have ways that you can interact with the APIs without even having code running. So for example, I can use the API Explorer, which is baked into Catalyst, to make test requests. And then I can also emulate an application using the CLI. So if you want to kind of test what does it look like to receive an invocation request or a pub sub message, you can do that using the CLI without having any code. So there are a lot of ways that you can interact with Catalyst from your local development workstation and from your applications to make interacting with the API super easy and seamless. Okay, cool. So I want to hand it off a little bit. We won't spend too much time on this, but before we dive into kind of the big part of the session, which is going to be a pretty comprehensive demo, I want to give the floor to a couple of our users who participated in the AWS hackathon that we had a couple of months ago. The product has definitely evolved a lot since then, but these were just really good use cases, really involved, users who have gotten really involved in Catalyst since then. And so just kind of want to give them the floor to talk a little bit about their solutions and their experience with Catalyst thus far. So if you weren't part of the hackathon, which I think several people on this call probably aren't familiar, we had 3 hackathon winners, all of which created really impressive applications, and it was a really cool experience. And we will be doing another hackathon in a couple of months, so definitely keep your eyes peeled. We want to do as many of these hackathons as possible to get as much user feedback, especially during this public preview phase. But I will kick it off first to my friend Rosius. Rosius built a deliveries app, but he has also gone on to build many Catalyst apps since then. But Rosius, if you just want to talk a little bit to what you built, what your overall experience was like, some of the use cases you found valuable for Catalyst, that would be amazing.
Thanks a lot, Kendall. So my name's Aloysius Nzimufo, and I built the package delivery service. That was actually, before building this with Catalyst, I'd actually built this using a different stack on AWS. And I just want to say that the ease at which I could build the application with Catalyst was way higher than the ease at which I could build that was way higher than the ease at which I built the application using a different stack on AWS. So Catalyst actually made it really easy. That's it, from the idea to the final product. The time from idea to the final product was so short, and the code also was so small that I could actually manage it on my own without getting too many people involved. So the problem actually the solution surrounded around the problem which I have where I live. So when you order food or when you order something online, you don't really get inside analytics or an inside view of how the item arrives or how the item reaches you. So I always like to see or to know where my food is, or how long it takes to arrive where I am, or where the delivery agent is currently at. So with that, that problem actually made me create this solution using a stack on AWS. But when I heard about Catalyst, I now had to recreate the entire solution with microservices on Catalyst, and finally submitted the solution, and here's how I got to it. So it was really amazing using the Catalyst APIs, and since then I've been developing different types of applications with Catalyst because it's just too easy to it requires less effort than when I use different stacks. And that's all I really have to say about that. Thank you.
Thanks so much, Rosius. Yeah, really appreciate all of your contributions. It's been amazing to see what you've been able to do, and you've really pushed the product a lot as well. So we're really excited to continue working with you. And I definitely feel that way with anyone trying out the product, right? We're really eager to work with you to make sure that it meets your needs. And that involves not only all the good feedback, but also the hard feedback to make the product better and stronger. So thanks again for all of that as well. And then, yeah, I will pass it over to Wit. I know I made a quick reference, but just like a little bit of backstory. Once again, Wit is an existing Dapper user, is a little bit more familiar. Rosius came in without the Dapper background, and and Wit came in with a Dapper background. So we get a little bit of a different perspective. So Wit, I'll hand it over to you to talk a little bit about your Invoicer solution.
Great. Hi, I'm Whit Waldo. I built the Invoicer proof of concept running atop Catalyst. Largely, it was just a project to kind of test out all the different pieces of what Catalyst has. Really kind of put the key value store to test, the pub sub workflow, and try to just really play around with an idea of building an application that could um, be controlled entirely via email. Receive emails, kick off workflows based on those emails. Build PDFs that essentially assemble invoices over time, and then again send more emails to verify that those are they're properly formatted or not, to use the user interaction components of the workflows, and really just put that on Catalyst. And like the other hackathon participant, really found that it was super easy to use this on Catalyst. The code changes themselves are trivial. Swap out 3 constants when the client is being registered to point to Catalyst instead of the local sidecar, and it fundamentally it worked. So a good experience, and it's like using Dapper. So that's because it is.
Awesome. Thanks, Whit. Sorry, I wasn't sure if I was muted yet, so I was searching for that bar. But yeah, thanks again so much for the contributions, the feedback. It's really good to get different perspectives. And so yeah, really appreciate y'all's participation, and hopefully that gives everyone else on the call just like a little bit of an understanding of some of what people have been building and ways that they've been testing out their product, in the previous stage that we were in that private preview stage. Okay, cool. So now we are going to jump into a bit of a Catalyst demo. And this demo is going to use all of the APIs, and I just kind of wanted to set up a little bit of what you're going to see. But this solution is essentially an order process, and it's all written in Python, and we're going to be running it locally and interacting with the various Catalyst APIs. We're going to walk through the different concepts. We're going to take a look at the UI. It's going to be a very kind of ad hoc, fun experience for all of us. And so, yeah, hopefully you'll get something out of it. You'll kind of see the different APIs. We'll walk through them, talk about what the code looks like, talk about what the components look like, and then talk a little bit about how we can navigate the UI and get insights. So in this case, I want to call out PubSub specifically. So in our solution today, the order processor workflow is essentially going to kick off an order process. And as part of that, it's going to be publishing notifications. And these notifications are messages that give insight into the stages of the workflow that are being completed, right? So think of it as almost like a status update. So this could be, you could have a user interface that you want to subscribe to messages and populate the, maybe the user's order process on their screen, right? It could be, another downstream or upstream system that needs to react or respond to specific events as they occur. But ultimately for today, it's just to make a quick like workflow visualizer. So anytime that the notification service receives a notification from the order processor workflow, it will display it on a user interface. Okay, so that's how we're using the PubSub API. So a couple of things that I just want to call out conceptually, and then we will see this when we get into the demo. So the first thing is you see all of these applications have this Catalyst icon, and that is essentially its app ID. So for the order processor workflow that's running on my machine, it will have an associated app ID. Same for notification service, inventory service. So just as I mentioned, the outgoing requests, order processor is going to make a request to its app ID using the PubSub API. It's going to specify a component, and then we're essentially going to have a subscription for the notification service that says, I'm listening for incoming PubSub events. And its app ID will receive it in Catalyst and deliver it to its endpoint. So the notification service application endpoint will be embedded in the app ID so that they basically function as, it functions as a proxy almost. Or not almost, pretty much exactly like a proxy. Okay, awesome. Yes, we can talk about that on a future slide. So another one is invocation. So as I mentioned, this is a little bit different, right? There's different communication patterns when it comes to microservices. This one is going to be direct service invocation. So we're basically going to have the order processor workflow make a call to the inventory service, which is potentially running on a different compute, right? And so it's going to do that through the service invocation API. So my order processor workflow makes a request into the invoke API. It specifies the app ID that it wants to invoke. That request is forwarded to the inventory service on its endpoint, and will essentially then respond with provide a response, since this is a synchronous call. Same goes with the other external services. And we'll also talk about different patterns, right? Technically speaking, all of these, all of the logic performed by these various services could technically be in the same application via activities, but you can also externalize them, which might be good for like scaling purposes, right? If you want to scale the inventory service differently than maybe some of the other services that the workflow is interacting with. I was going to show you state, so I'll just show it to you on here. whenever we make a call to the inventory, or whenever the inventory service is processing, it's going to call out to a state store. And so I don't know where that slide went. I apologize. But the inventory service will be calling out to a state store, which is going to allow it to essentially retrieve the inventory, check and see if something is available, and return a response based on that finding. And then overall, this whole thing is working as part of a workflow, right? So the important part is this is essentially all part of a large transaction. So, if certain things fail, I have the ability to then compensate. So that's essentially, this is going to be a Saga pattern workflow. There are different workflow patterns that you can use within the programming model. It's all code-based. So this all is being orchestrated by the order process workflow. And you'll see here that I kind of have this bidirectional arrow between the order processor and its app ID. And the important thing to call out about workflows, the way that this works is that the order processor workflow uses a workflow authoring SDK. And when it comes online at runtime, that SDK is going to initiate a bidirectional gRPC stream with its app ID. And so this is how the work stream is open for those workflows to get scheduled, for the app ID to essentially act as the workflow engine. And so there is no external endpoint exposed on the order processor in this case, because the connectivity is established outbound from the application and inbound to Catalyst. And then we also make use of a binding, which we'll talk about in the demo as well. It's not much of a slide just because it's so small, but we will see it in action here in just one moment. And we will switch over to take a look at some code, if that works for y'all. Okay, so I'm going to pull up the Catalyst portal. Okay, awesome. So we are going to start out by just kind of taking a look at the portal and getting familiar with Catalyst before we dive too much into each of these APIs. But we'll basically walk through the workflow. We'll talk about each call it makes. And once again, if you have any questions once we get into the weeds of that, please let me know. So let's start by looking at the call graph. I think this is a good place to kind of get your bearings and see what's going on. So the same way that I showed you those diagrams that I made, this is definitely a lot more fun one to look at. But what we're seeing here is the application graph in our Catalyst project. So think of the application graph as kind of being a trace rendering of how requests are being made through all of my applications that are associated to an app ID in this project. So it should look really familiar based on what we just saw. We have our order processor, and we can see this dashed line means it's making a pub sub request. And it's using this pub sub component. And if we click in on that, we can actually see the type is pubsub.diagrid. So it is using a Diagrid hosted infrastructure service for the pubsub API. But once again, this could easily be swapped out for any number of pubsub brokers, which I'll show you in just a second. And then we can also see that our notify application is subscribing to messages specifically that are published on this broker. We also see a couple of other things happening here. So we see 3 service invocation requests, which we once again walked through on the slides. And then we see those 2 slides that I did not put in the deck, which is that inventory service calling to a state store called inventory. In this case, once again, it's a Diagrid managed key value store. So we provide that as an infrastructure option for users who don't necessarily want to be as opinionated or don't have to, don't want to deploy the infrastructure, don't want to deal with CloudFormation or ARM. You can just use the same kind of Catalyst resource model to create and provision infrastructure services. And then last but not least, one that we haven't talked much on is bindings. So my payment service is actually going to use an HTTP binding to call a generic endpoint. And in this case, that generic endpoint is for Square. So if you're familiar, Square is a payment service that essentially allows you to pass in payment information, take payments. I'm sure you're familiar. We've all interacted with it in every store pretty much that we've gone into. So the payment service will call out to Square with the payment information, and it will either return that the payment succeeded or that the payment was declined. And I actually have this in the demo. It's going to alternate between passing and failing, so that we can see sort of what it looks like when the payment fails. How does that affect the workflow? So All of these green boxes represent the respective app IDs that we talked about earlier. So they all represent our applications. And then once again, the yellow boxes are representing those components. So if we take a look at the app ID, we'll see just like a couple of interesting pieces of information. So one is my API token. I have to pass this in with every request to the Catalyst APIs, right? Totally makes sense. If you've ever used any other API platform, there's some kind of like authorization header or token. In this case, through the Dapper API token header or through the SDK, where you set that header as well, you can essentially configure an API token to make these requests. In addition, we also have an app connection. So this means that the inventory service is receiving any incoming requests that come to the inventory app ID on a local address on my machine. So this is really, really useful for when you're doing local development. You can essentially say, hey, deliver any incoming events to my app ID to my local machine so that I can process them in my local code. And then once again, a good example of what this might look like in another another architecture. This is an app that Rosie has actually built and contributed to Diagrid. A good example of this one is like the endpoint is an an AWS load balancer endpoint, right? So these are running on ECS. There's a load balancer in front of them. So you can see the app connection is no longer running locally, pointing to a local endpoint, but is instead pointing to an app that's running in AWS. And one of the things I want you to keep in mind, right, this is a public preview product. We completely understand that most of your applications won't have public endpoints. So that's definitely something we're going to be mitigating, not only through app initiated actions, which remove the need for an app endpoint, but also other potential, VNet integration, private link type considerations. So that's just something to keep in mind. Okay, cool. Just kind of wanted to draw that parallel to make it a little bit more real for you. Sorry, I don't know if you can tell I'm the product manager, so I have lots of projects. But yeah, so that kind of gives us a little bit of clarity on sort of what the app ID looks like. We can also see some things like what components that this particular app ID has access to. So as I mentioned, our app ID is truly like a unique identity for the app. So through the app ID, you can say that it has access to particular components. So in this case, the inventory service can access the inventory state store, but no other application can. And that's because we don't need every application to access the database. We only need the application which is using it, right? Totally least privileges type of implementation there. So we also can see things like app metrics. I might not have any metrics, honestly, on this particular service. Yeah, it's been a bit, but we can maybe go over to our order processor and we should see maybe, let's see if we get a few more calls if we look over time. Yeah, so we can see like, you can also investigate what API calls are being made with a particular API token. I can drill in and see like, what's the name of the pub sub component. So in this case, I'm publishing messages to the component called PubSub on the topic notifications. So this is the type of information that you can find at the app ID level, right? Like what APIs am I calling? What's the latency? How many requests per second? What's the error rate? So you can see earlier, I was actually getting 100%. My workflow was failing. This was something I was working through. So nice, solved it. Great. So that's kind of the app ID. Hopefully that brings some good clarity to you. Another thing that I want to talk about is that component concept. So here's what it looks like in the user interface. We can see that we have a type, which specifies what API is this connected to. So is it the bindings API, the PubSub API, and then the target in this case is going to be like, hey, what's the actual binding? So for example, this one is an HTTP binding, but in these cases, you can see the target is actually clickable, and that's because the target is an infrastructure resource hosted by Diagrid. So if I take a look and click in on inventory, I can actually see the key value database where my data is being stored. So this is kind of an alternative to maybe using like a DynamoDB, for example. And then same goes with PubSub, right? You saw that I had a component called PubSub and it's pointing to specifically a Diagrid broker. So we can actually go in here and we should be able to see that we have a single topic that I've published over 2,000 messages to it and that my notify subscriber has processed all of them, which is awesome. So this is another just added benefit to the Catalyst platform. It's like removing infrastructure deployment for backing services. But If we want to go in and create something of a different type, you can see that we have a wide array of different services that are provided. And in the case of state, we can do things like, filtering by the capability that it supports. So like, does this support being used as like a workflow backend? Does it support state stored transactions? Does it support time to live, where I can actually expire key value pairs based on a time frame that I specify? Or does it support the query API, which allows me to query a set of key value pairs using a Dapper query syntax? So just a good example of how you can onboard your own infrastructure. And these mostly contain connectivity information, right? So for example, if I want to connect to DynamoDB, I can choose a scope, which is once again, which app IDs can access this particular component. And then we can select an authentication profile. So in AWS today, this is a good example of something that will improve in the next couple of months. You have to pass in credentials in order to grant Catalyst permission to access the underlying DynamoDB instance. Moving forward, our goal is to remove this like password requirement, and instead you can use and like authenticate to AWS without passwords, right? Using more of like an identity provided by AWS. So that's the goal, right? We can grant access to your AWS account without passwords, or Azure, depending on the component type, that would obviously have a different requirement. So that's the components. And then subscriptions. So we talked about subscriptions, right? This is just a good example of how my notification service is actually subscribing to those messages that are coming in and being published. So we can see it's targeting the pub sub component. It's a topic subscription on the notifications topic. And anytime that a message comes in, the notify application will receive that message on the notifications route in the application. So that's what this topic subscription is doing. So the call graph we've already taken a look at, but if we take a look at API logs, what this is going to provide us is insight into all incoming requests and outgoing requests. So you can see here, I was testing something out and I was getting a 400, made a change in my code, was able to resolve that. But if I filter that out, I'll be able to see a bunch of successful requests. So for example, in this case, I'm seeing all of the outbound requests going to my notification service to publish that message to that application. So we can essentially filter by app ID and get a good understanding of kind of what each app is doing. So for example, the order processor published an event on a particular component. It also made a request to the shipping service, right? All of this filterable and easy for you to get visibility into kind of what's happening on the API request level. And then another really cool feature is the Workflow Explorer. So we can take a look at a few workflows here and actually see what's going on. So I've shown you this from like a graphical perspective, but what does it actually look like to use the Dapper workflow API along with a variety of other APIs? So the binding API, the service invocation API. So we can see here that an order was started, and that order was for me, and I bought oranges for $11. And we can see that the first task that was scheduled within that workflow was to publish an event to the notify service. And this is what the event was, that it received an order and it gave some order context. We can also see that another activity was scheduled, which was to reserve the inventory. So what this is going to do, it's going to call that inventory service. It's going to check the database. It's going to see if there's any inventory available. And then depending on that output, it's going to return. So we can see that the items returned were reserved successfully. Amazing. So as a result, we publish a notify event that we reserved inventory. Next up is actually submitting the payment. So this is when the payment service is called and it uses the output binding to call Square. So in this case, we can see that the task was completed and we got a 200, which means that Square actually processed our payment and that it was successful. So we're going to send another notification, which is a published message. We also have another task, which is let's now submit it to the shipping service. So the shipping service receives the message. It's going to, in this case, simulate work because we didn't actually have any logic in the shipping service really, but it's going to make the call, submit it to shipping. And then ultimately what's going to happen at that point is that it is going to notify that the order was submitted. And then it's going to send order completed to the notify service. And then at that point, we've completed the workflow. And in this case, we see that the order was processed successfully and we got a success message of true. So this is another really great feature, right? A lot of people love Dapper workflows, and it's a great programming model for people who want to be in the code writing workflows in a resilient way. And now you have a visualizer that you can use to really navigate and understand what happened. And this is a good example of something that will improve a lot over time as we enhance and add new features. We'll be able to filter and introspect, and ideally have more traceability in terms of like where each of these activities is being targeted, that kind of stuff. So yeah, that's kind of the whole solution running. So with the last kind of 5 or so minutes, let's get into a couple examples of what this code looks like, if that's cool with y'all, and we can actually see it running locally. And yes, I will publish this code today or tomorrow, and then we will send it in the follow-up email to the webinar so that you can play around with it yourself and get up and running. So great question. All righty, let's pull up Visual Studio. Close that out. Okay, so I'm going to zoom in a little bit. There's a lot of code, lots of stuff going on, but we're just going to briefly kind of walk through the workflow at a high level. I'm going to run it locally, show you a couple of code paths so we can take a look at the workflow visualizer, and then we'll essentially wrap up from there. And let me just kind of move this around a little bit so that I can get a good view. Okay, awesome. So I was running some load earlier. So the first thing that we're going to walk through is just the code. So all of these are written in Python. You can see here that I have an app per app ID, which is what we discussed. And I just want to kind of briefly show you how each of these APIs works. So in my order processing application, I'm using that workflow SDK. So you should see here that I have my Dapper workflow and I have my Dapper client. So I have my workflow client, I have my Dapper client. The workflow client is what's going to help me interact with the workflow and to create and author that. And then the Dapper client will help me make the outgoing requests to other services like service invocation, PubSub. One thing I want to highlight is we talked about the swappability of components. That's all dictated through the name of your PubSub. So in this case, remember we looked at the components. I had a component called PubSub. So I'm going to tell the API to call the v1 publish endpoint with the name PubSub, which is the component. And then when I publish messages, I'm going to publish them to the notifications topic, which is what that notify service is listening on. So you can see here's the actual method. Whenever I kick off a workflow, it's going to execute this logic. So you can see basically each of these happens in an activity. So the workflow itself is essentially going to dictate the structure of the workflow, the sequence, but all of the activities is where the compute and the logic and computation is happening, right? So I have an activity, which is going to be my reserve inventory activity. I'm going to also make use of some other really cool workflow features. So this is just another highlight of what like Dapper and Catalyst enable is like you can have a workflow wait on approval from a human. And I can show you what that looks like in just a second. Depending on if the timeout is met or the approval is received, will dictate the way that the workflow continues. Once again, we're also going to submit the order to the payment service through the submit payment activity. We're going to input that order. We're going to submit the order for shipping. So a lot of this is what you already saw. And you can see that in, I guess, about 60 lines of code, we have created the entire workflow definition and all of the, and that's essentially authored right there. And then each one of these is actually calling these methods. So these methods are what these are the activities that are being called by the workflow to actually execute the external requests, any, like I said, computation. So we can see here, look at how simple it is to invoke another service. You can see it's using the Dapper client. We say invoke method. In this case, we're invoking the inventory app ID on the inventory reserve route, and we're making a post and we're passing in the order. So in one line of code, I've basically been able to do complete network resolution wherever that inventory service is running. In addition, same for submission of payment, we see the same invoke request, and then the submit order to shipping, same invoke request. And so very, very simple, straightforward. And this is the actual controller method that takes in and starts the workflow. So you can see here is where the workflow actually gets kicked off. So we can see whenever I make a post to the orders method, it is going to schedule a new workflow with of type process order workflow with the input of the order, and then an instance ID, which in this case can be generated, or we're going to pass in the order ID. I'll show you a couple more quick APIs, run this, and then, say sayonara and thanks for joining. I'm going to show you the payment service. So the payment service, once again, is being invoked by the order processor. But you can see here that I have this payments charge endpoint. And what it's going to do is it's going to generate a create payment object, which is what Square needs in order to process the payment. And then I'm going to invoke a binding with that particular payload. So in this case, the binding is Square API. I want to use the create method, which is essentially a post that's backward compatible. And then I'm going to log if it was successful or not, right? And this is super, super simple, super easy. I don't have to use the Square SDK. I can just use Dapper, and I can just use that binding. And then last but not least, I will show you the inventory service, which uses the state API. So once again, super, super simple code. What I'm doing here, we'll do the get inventory. So what I'm doing in this case is I'm just calling the get state with the name of the state store, which in this case is inventory, and the key that I want to retrieve. And in this case, I'm retrieving all of them. So I'm going through like a dictionary I've created, but ultimately single request, single line of code allows us to call to any state store. This could be Dynamo, this could be Cosmos, this could be Diagrid, but very, very simple, very straightforward, very consistent. So just kind of want to show you a couple quick examples. I won't get in too much to the Diagrid dev start command today, but just know what this is doing is using a local config file to run all of the applications alongside of injecting the environment variables that the SDK needs that we mentioned earlier. So what this is doing, you can see it's connecting to my local endpoints here. It's running all my applications, and now I can basically start making test requests that we should be able to see in the Catalyst console. So first, let's do, for example, get inventory. So we already took a look at the inventory service that's running in Catalyst. This is returning for us what's stored in that database using that get state endpoint. Okay, now I'm going to submit a simple order for Bob, and what we can see is that workflow is being executed, which is great. And we can see that it's processing. We can see that the payment is being taken. So we should be able to go into the UI in Catalyst and just take a look at this in real time in context of what we covered just now. So if we do a quick refresh, we can see that order came in for Bob at 12:58, and that in this case, the order was processed successfully. Another cool thing that I can do is I can submit an expensive order. So in this case, my niece Cecilia, who's 2.5, is just really hankering for an iPhone that's $1,299. Well, oopsie, if we go and take a look at this workflow, we will actually see that it failed. And it didn't fail, it completed, but the user didn't get their order because, hey, we don't actually sell any iPhones here. So we're going to change this to Apple, and we'll do a save. Or actually, we'll do Kiwi because I know that one is in there. And we'll submit this. So we'll say that she bought $1,000+ of Kiwis, which most likely would never happen, but maybe she's a Kiwi lover. And what we can see is this is going to continue running because we created a timer and said, hey, this is waiting for approval. Like Cecilia can't go spend $2,900 on not $2,900, $1,299 on Kiwis, right? So I can go in and actually like decline that request. So I can say like, hey, for this particular instance ID, I'm going to decline or approve, right? So we'll approve it just to see it moving through. So it's waiting for this event. This event can come from another application. It can come from it can be raised in any way. It's waiting for this named event. So if I refresh, what we should see is that it resumes. Amazing. So we see that it resumed and the order was processed. So lots of really cool stuff that you can do between, this app makes use of all of the APIs, fairly straightforward code. I'm not a Python developer, and I was still able to work with Dapper, which is amazing. And Catalyst just makes it all the simpler, right? I don't have Dapper running locally. I don't have to manage an open source project. I get a fully managed user interface, an experience, a developer experience. So yeah, I hope that all of you will try out the product. I hope that you'll play around with it, see if it meets your use cases, give us feedback. But ultimately, I hope you're walking away with a much better understanding of what Catalyst provides you. I know that we need to wrap, so I do want to leave you with with one thing here, if that's okay. So Rosius has been working on an AWS application that is a group chat app. So it essentially has a user interface. It uses SNS SQS. It uses DynamoDB. We have a fully scaffolded pipeline where you can deploy all of the resources to AWS and get up and running really quickly. So just wanted to highlight that that example exists. And maybe Rosius, do you have it up? Do you have the chat up? Maybe you can give me a little response. So this is another application powered by Catalyst. I actually showed it running when I switched over to that AWS endpoint that I showed you. So maybe Rosius, I can send you a quick message, and if the demo gods are with us, hey, hope you enjoyed the webinar. And maybe we can get a little response. He's on the spot. He may not have had it pulled up. So let's see if he can give me a little response. Okay, yeah, he thinks it's running. He enjoyed the webinar. So yeah, definitely go deploy this app. It's another really great example of Catalyst in action. And we're really excited to see where Catalyst goes. So if you have any questions, please continue engaging with us, sign up for our newsletter, and we'll be in touch.